Observe very carefully. So as we know in the last previous classes, we all studied what is Newton's first law and as well as Newton's second law. So Newton's second law will gives you the relationship between force and acceleration. That is what F is equals to mass into acceleration. We have been found. And Newton's first law will says that the body in state of rest remains in rest. The body is in uniform motion. Uniform motion in a straight line remains in state of uniform motion unless it is compelled by an external force. Is it yes or no, guys? Please respond. That is what we studied about Newton's first law and as well as Newton's second law. So Newton's first law also we used to call it as what? Law of inertia, or we can say Galileo law of inertia, or we can say Newton's law of inertia. Now, if it comes to here, Newton's second law, if you want to understand, we need to know one more word which we used to call it as what? Momentum. So that is what we studied in the last class also. So rate of change of momentum only, even we can say change of momentum in a given time period is only we used to call it as force. Is it yes or no, guys? Please respond. Everybody. So that is what we all discussed in the till yesterday's class. Now, today's class we are going to study the last law of Newton's. That is what Newton's third law of motion, which will describe the motion of a moving body. That is what we used to call it as Newton's third law of motion. So, first of all, directly, I'm going to say the statement of Newton's third law of motion. That is what is that means? For every action, there is an equal and opposite reaction. Please, all of you write. What is that? For every action, there is an equal and opposite reaction. That is only called as Newton's third law. For every action, what is happening, guys? For every action, there is an equal and opposite reaction. There is an equal and opposite reaction. Is it okay, guys? Everyone, please respond,
Yes,
guys. Now, let us consider two bodies. All of you observe. I am going to take you now two bodies. So this is body A and another body. Let me take now, and this is body B. So how small or how bigger is doesn't matter. Do you understand? So one body is may bigger, one body is may smaller. Is not an issue. Now, if you notice it very carefully here, for example, this is body A. I understand everyone, and this is another one is what? Another one is what? Body B. Is it okay, Harish? This is one is body A and another one is what? Body B. Let me consider this is body A and this is what? Body B. Now, if body A will hit the body B, do you understand? Consider two bodies A and B colliding and A exert a force on B. Then that is what we used to call as. What is that called as? Action. What we used to call? What we used to call, guys? Action. Understand? So A and B both collide each other and A is exerting pressure on B. So whatever the force exerted by A on B is called as what? What we used to call, ready? Action, we can say. Okay. Now, according to the Newton's third law, B also will exert an equal force on A, but in opposite direction or same direction. Check it, everybody. Opposite direction or same direction. Why no people are no opening the mouth? Is it opposite direction or same direction? Opposite direction. Remember, if for example, if we'll take, if this is Harish and this is, let me consider Danishka. So Harish is bigger in size and Danishka is little smaller in size. Now it doesn't matter. Size is not a problem. Do you understanding? Size is not a parameter. All of you are you understanding? Now, if Harish will exert 50 Newton force on Danishka, then Danishka also will exert how much force on Harish, guys? How much force?
15.
same 50 newtons, but Haris is exerting in this direction, Danishkar is exerting in this direction. So the person who is going to exert force on understanding first force exerting on second body, then that is what we used to call as action. What we used to call, guys? Action. Now, when first body will hit the second body, then second body also need to hit the first body. Is it yes or no? Yes, please respond.
Yes, sir.
But
Yes,
in
sir.
opposite
Yes,
direction,
sir.
opposite direction, that is what we can say. This is what we used to call as reaction. What is to call? Everybody?
Reaction.
Reaction.
So once again, I'm trying to say, understand how many bodies we have? Mitakshri, Akilan, everybody. How many bodies we have?
Two.
Two bodies. So what is the naming of the two bodies I have been taken? One body is A, another body is what? B. Now, if consider two bodies A and B colliding each other, what do you mean by collide? Anybody can tell what do you mean by collide? Both will hit each other. Do you understand? Both will hit each other. Now, A exerting force on B, that is called as what we used to call A exert a force on B, and that is only we used to call as what? Action. What we used to call? Action. All of you should remember. A exert force on B. Force on B is known as what? Is known as action. All of you should remember. This is what you people know. Now, A hit the B. Now, according to the Newton's third law, what is the definition? Everybody read here. According to the Newton's third law, what is the definition? There is an equivalent. Please respond. There is an equivalent. Opposite reaction is there. So that is what we called as opposite reaction is there. That is only Newton's third law. So if A exerts force on B, according to the Newton's third law, B exerts an equal force on A, but in which direction? Same direction or opposite direction? Same direction or opposite direction? Please respond.
Opposite
Opposite direction. That is what we used to call as
Opposite direction.
reaction. What we used to call reaction, right? B exert an equal force on A. Reaction. B exert an equal force on A, but in which direction? But in opposite direction.
Opposite.
Yeah, opposite direction is known as reaction. So that is what you have to remember. So for every action, there is an equal and opposite reaction. All of you should remember. For every action, understand? For every action, there is an equal and opposite reaction. Are you understand, everyone? So if you are applying the action, if you are applying the force on somebody, that body is also exert force on this body, but in opposite direction. This minus indicating what, Hari? Minus indicating what? Opposite direction. Here you can keep equals to sign. I forgot to keep. So equals to. So that is what minus indicating force is exerting in opposite direction. That is what. So till here, everybody note it down. If you have any doubt, please kindly let me know. Is it okay, guys? Yes, please. That is what it is. Make it. Yeah. All of you understand Mitakshri, Vardhani, Kaushik, Akilan, anybody having doubt, you can ask me. This is what. So from this we can say every action is accompanied by whom, guys? You have to answer. Every action is accompanied by whom? Accompanied by whom?
Equal opposite reaction.
Opposite reaction. That is what we used to call as. What is that called, Reddy? What is that called? Opposite action is called as reaction. Okay. So all of you should remember, every action is accompanied by a reaction. That is why we can find that forces always exist in pairs or single one. Is it pair? Is it single body? Is it possible to produce action and reaction? Like Vikram movie, some movie. He himself, he will hit and he will come to next side. Is it possible to produce action and reaction in the same body? Anybody? Anybody can tell. Is it possible to produce action and reaction in the same body? Or is it always the force action and reaction will acting in the two bodies or single body? Anyone? Yes, please respond. Is it possible
bodies,
to
sir.
take action and reaction in the same body? Like same person is sitting and same person is crying. Is it possible? In himself?
No, sir.
No, himself it is not possible. Same way, single body cannot do action and as well as reaction. Always these forces are existing in how? Pair it is existing. What do you mean by pair? Anyone? Pair. Pair means how many? Two objects. That is what you have to remember. So a single object force cannot exist. That is what you have to remember. So single isolated object, understanding single isolated force cannot exist. So action and reaction do not act on the same body. Always how many bodies is needed, Hari? Ready? Always how many bodies is needed? Two bodies is needed. So always they involve two different bodies. So that is why you can see they do not cancel each other. And it is always not required that two bodies should have same physical contact to exert force on each other. That is also you have to remember. So without physical contact also, force bodies can exert the force on each other. So but anyhow, action and reaction always will takes place in single body or two different bodies. Everybody try to answer. Akilan, Dharnishkar,
Two bodies, sir.
force is exerting on two different bodies. It is not possible to exert the action reaction in single body. All of you should note it down that every action is accompanied by a reaction. Every action is accompanied by a reaction. Every action is accompanied by a reaction. Thus, we find that force always exists in how, guys? Thus, we found that force always exists in how?
Yes.
Always exists in how? Pairs. Okay, pairs. All of you should remember. So, action should done by one body and the reaction should done by another body. Okay, so body one and the reaction should be on body two. So like that only, always the force is exerting between a pair. That is why a single body cannot exert action and reaction both. Understand? So always you have to remember that is the reason always two bodies is involving in Newton's third law and they do not cancel each other also. Okay, that is what. Now for example, one more thing I am saying, is it physical contact is necessary between two bodies? I am asking, is it physical contact? Is it physical contact is necessary for action and reaction? That is what I am asking. Is it all the cases? For example, I want to hit the wall. Is it possible to hit the wall without contact the wall? Anybody? I want to hit the wall. Is it possible to hit the wall without contacting the wall? Anyone?
Yes, sir.
No. Understand? Suppose I want to blast the balloon. Is it possible to blast the balloon without touching the balloon? Yes, please. Yes? Nobody is answering.
We can throw items, no, sir.
Yes. So most of the cases, physical contact is necessary, but physical contact is not necessary in always. Okay. So physical contact is necessary. Is it true? Always it is not required. Why means two kinds of forces, I will say example, which will act in two different bodies, but they are following the Newton's third law. That is what? First one, gravitational force between the sun and the planets. Gravitational force between the sun and the planets. Understand? Is it any physical contact, sun and the earth or sun and the planets? Anyone? Sun
No,
and the
sir.
earth and sun and the planet. Any doubt? Anyone? That is what. So physical contact between the two bodies is always not necessary to act the forces. All of you should remember that. So earth is exerting force on sun and sun is also exerting force on whom? Sun is also exerting force on whom? Earth,
Planet.
planet. That is why that is called as understanding action and reaction. Sun is exerting force on earth is called as action. Earth is also exerting force on sun. That is called as what we used to call reaction, we can say. So all of you should remember the point, everyone, right? It is not required that two bodies should have physical contact. It is not required. It is not required in all the cases. I am saying some cases it is required. Physical contact is required in some cases do not require. It is not required that the two bodies should have physical contact, that the two bodies should have physical contact to exert force on each other, to exert force on each other. So what is the example, everyone? What is the first example, everyone? Gravitational force between whom?
The sun
Gravitational
and the planet.
force between sun and the planet. Sun and the planets. So this is also, it is not physical contact is not there, but still action and reaction is there. Second one, force exerted between two magnets which are kept apart. Force exerted between two magnets. They will attract or not, Hari? Or they will repulse or not? Yes, please. Two magnets, okay, which are kept apart. Kept apart. Are you understand, Arun, Kailas, Gokul, Danishkar, everyone? So physical
Yes, sir.
contact is needed. If no physical contact also, then also the force is exerting between the two bodies. So till here everybody noted down. So this is what, if you notice it, so what is Newton's third law of motion and how it is exerting between two bodies. Now everybody till here noted down. Just wait for 1 minute, I'll be come back, or else we'll proceed. Clear, everyone? What is Newton's third law? So there is an action. If there is an action, then definitely there will be a reaction, but that reaction will be in what? Same but opposite side. That is what you have to remember. So every action, there is an equal and opposite reaction. That is only we used to call as Newton's third law of motion. All of you. Is it okay, guys? Yes, please respond. So that is what you can notice it here. If we'll go to the page number in our textbook, page number 64. All of you open page number 64. Try to open your page number 64. Not in NCRT. The book, practice book, they have given correct. So all of you see that picture, everyone. Can you see that, everybody? So if you'll notice it there, what is happening in that picture? Everyone can read here. See here, when a boy, you see the boy is standing on the roller skate. Is it yes or no, Hari? Ready, Danishka? So a boy is standing on the roller skate. So you can see skating. Now you will notice it very carefully. The boy is applying force on the what, guys? The boy is applying force on what? The boy is applying the force on the wall. So a boy is it possible to apply the force without touching the wall? Anyone? Is it possible to apply the force without touching the wall?
No,
No,
sir.
sir.
No, it is not possible. So that is what, they must be in contact, or even very less forces without contact also. So now a boy is exerting force on wall. So then what is this called as? Action or reaction? It is called as what?
Action.
Action. You can see when the boy exert a force on the wall, then the wall also exert an equal force on the boy in the opposite direction. That is why you can see when I try to push the wall in the forward direction, you can see then the wall will apply same equal and opposite force on me so that I will move backward direction. Is it yes or no, guys? You can see the opposite force exerted by the wall makes the boy on roller skates move backwards. So then that force is called as what? Action or reaction? That force is called as reaction. Understand? Now, for example, here Kaushik is standing. Next here Arun Kailas is standing. Here Danishkar is standing. Now, everybody, Danishkar applied 10 Newton force. Arun Kailas applied 100 Newton force. Kaushik is applied 1000 Newton force. Who will go back? Everybody can tell. Who will go back? More longer distance. Who will go more longer distance? Anyone?
1000.
Kaushik will go more back longer distance. Why? Because
So
that,
because
He
you
exerted
applied
more
more.
force.
that is what you have to remember. So if Danishkar is applying 10 Newton force on the wall, then wall also will exert how much force? Same 10 Newton force, but in opposite direction. So Danishkar can move little bit back. Next, Arun Kailash, you can see he's applying 100 Newton force. So that same 100 Newton force so that he will travel a little bit more. But he's applying 1000 Newton force so that he will travel even more longer distance. Is it okay, guys? That is what. So reaction force will be depend on what force? Action force. So always whatever the force we are exerting on the object, the same amount of force will be exerted by that second object on the first object in opposite direction. Is it okay, everybody? Yes, please respond. All of you. So that is what you have to remember. So if
Yes,
you are
sir.
pushing the wall, suppose you people can wear the railings, this roller skate and try to push the wall with normally slowly. Then you people will move little bit. Forcefully, if you push the wall, then if you keep on pushing the wall more and more, then the wall also will push you back more and more, so that you will travel more distance or less distance. Reverse direction. You will go back away from the wall more and more when you are applying more force on the wall. Is it yes or no? Please respond, everybody. Yes,
sir.
guys. That is what. Next,
Yes, sir.
yeah, figure number 27, you can see there. Figure number 27, what is happening? Everybody can tell what is happening. Figure number 27, page number 65, you can see that. Page number 67, 65 or 67, figure number 27, what is happening? Everyone see that and tell me. A man is trying to pulling apart. Yes, please. This is what the picture, figure number 27. Do you have it or not? Everybody.
Yes, sir.
Yes, sir.
Yeah. Check in our textbook also. Kaushik, if you don't have a textbook, no need. You can see this figure, no problem. Now, a man is exerting force on the cow, but the cow is also exerting equal force back on the man. That is why you can see. So a man is trying to apply the force like this, means he is trying to pull the bull in this direction. So this is what we used to call as. What is this called as? The force exerted by a man on the bull is called as, what is to call? Action. Understand?
Action.
Now, bull is also trying to exert same amount of force on the man, but in opposite direction. That is what we used to call as what? Reaction. Understand? That is why you can say bull is also not moving forward and man is also not moving forward, because they both are exerting same equal and opposite force. Understand? That is what action and reaction. That is why we can say this is an example or illustrate to what? For Newton's third law of motion. Is it okay, Metakshri? Yes, please respond. So that is why we can say, according to the Newton's third law of motion, whenever one body exert a force on the another body, then the second body also exert an equal and opposite force on the first body. So that is what you have to remember. So the force exerted by first body and second body, what we used to call the force exerted by first body and second body is called as action. The force exerted by second body and first body we used to call as what? Danishka, everybody try to open your mouth. Arun Kailas, you also, Gokul also. So the force exerted by first body on second body is called as what? Action.
Action.
All of you should remember. Now, the force exerted by second body on first body is called as what? Reaction
Reaction.
is in opposite direction. That is why action is equals to, we can say what? Action is equals to what, guys? Simply we can say minus reaction. Okay. So minus indicating it is not minus. It is indicating what? Opposite direction. That is what you have to. Okay. So this is what. Next. In this picture, any doubt? Anyone tell me? All of you, are you clear? Any doubt, guys? Now, next picture, figure number 28. Everybody see that figure number 28. What is that? That is an experiment to demonstrate the, what is that? Demonstrate the Newton's third law of motion. Okay. Now, try to understand very carefully. This is the simplest experiment to prove that Newton's third law of motion. So totally I have taken how many when this spring balances? I have taken 2 spring balance. How many spring balance, guys? 2 spring balance. Are you understanding, everyone? Now, one side of the one spring balance, I have been sticked to the wall, or else I have been attached to the wall. That is what we used to call as hook. Have you noticed it? For hook, I have been attached. Is it yes or no, guys? Please respond. Now, both spring balance, I have been tied each other. They have been tagged each other. Now, at the second spring balance, at the end, okay, with my finger, I am trying to exert the force. Then, so that you can see the spring is stretching here. Have you noticed it? The spring is stretching here. So, on what is the force exerted here? You can notice it. What is the force exerted? The spring. Yes, please respond. What is the force exerted? By my hand. By my hand is 4 newtons. So whatever the force I'm trying to pull or push, this one is only called as, what is this called as? What we used to call it?
Action.
So
Action.
with this spring balance, I am trying to exert force, 4 Newton force on this B body. Do you understanding? So B body is also trying to exert same 4 Newton force on the A body. That is why you can see in the A body also, what is the spring balance reading? You can check it here. B also, what is the spring balance reading? Spring balance reading is same 4 newtons only. So A is trying to apply 4 Newton force on B, so that B is also exerting same 4 Newton force on A. So that is why it is called as what? What we used to call, everyone? It is called as reaction. Understand? So when we pull the balance A, spring balance A, it is exerting 4 Newton force on the balance B. Understand? Then the balance B pulls the balance A, spring balance A, with an equal force of 4 newtons. But in which direction? Same direction or opposite direction? Same direction or opposite direction?
Opposite
Direction. That is why we can say when spring balance A exert a force on action of balance B, then balance B also, spring balance B also exerts an equal and opposite force of reaction on balance A. That is why, since both are spring balance showing the same reading, how much is the reading it is showing? Check it, everybody. Both are showing the same 4 Newton force. That is why we can say action is equals to what, guys? Action is equals to what? Minus reaction, or we can say opposite reaction. That is what you have to understand it. Till here, any doubt, anybody can ask me. Is it okay, guys? Yes, please respond, guys. Yes?
Yes, sir.
As I told you, action and reaction always will exert on same body or 2 different bodies. Action and reaction is always exert on how many bodies? Is it the action and reaction in the same body? That is what my question. Is it possible to exert the action and reaction in same body? No, it is not possible. So action and reaction act on always how many bodies? 2 different bodies. Understand? Now, for example, let us take one ground. This is what the ground. Now, I have been placed a one big wooden block. Now you tell me, the wooden block exert the force on the ground. Is it yes or no? Yes, please respond. The wooden box is
Yes, sir.
the ground. That is what we used to say based upon its weight. Okay, so if the body is having more weight, it will exert more force on the ground. Less weight, less force on the ground. So this is what the weight exerted by a body on the ground. What we can call action or reaction. Anyone? What is
Action, sir.
action? Understand?
Action.
Action we can say. Now, when the body is trying to push the ground downward direction, then ground also will try to push the body in upward direction, so that the body upward force is acting by the ground. That is what we used to call as. What is that called as? Anyone?
Reaction.
Minus reaction.
As reaction. Understand? And this is what we can say. Here something is present. That is what we should call as what? Ground. Okay. So the force between the ground and this one. And this is what we can say, even what? A wooden block, or we can say box. So all of you should remember, when any kind of object, or else if you are standing on the ground, then you are exerting a force on the ground or not? Please respond. Are you exerting force on the ground when you are
Yes, sir.
standing on the ground? And ground is also exerting same force on us. That is the reason even we are not escaping from the surface of the ground. Always we are able to walk because of that. Is also one of the reason. Some pulling force is always trying to pull us, our body, towards to the ground only. That is why you can see always these rockets, space jets, everything will work with action and reaction only. So that is why we can say all are examples of what? Newton's third law of motion. What is that? Newton's third law of motion.
Third law of motion.
Yeah, Newton's third law of motion. So always it will take how many bodies? Action and reaction act on? Action and reaction act on single body or two different bodies?
Two bodies.
Two different
Two
bodies.
different bodies.
Remember that. Okay. So that is what. Now, little bit meeting is going to end. So all of you please remember, whenever two bodies exert force on each other, the force exerted by first body on the second body, we used to call it as what? The force exerted by first body and second body, we used to call it as what, guys? Action. Understand? And it is equal in magnitude, but in opposite in the direction. That is what you have to remember. Equal in magnitude, but opposite in direction to the force exerted by the second body and the first body. So the force exerted by second body and the first body, what we used to call? It is called as reaction.
Action.
Okay. So this is what about what is Newton's third law and how it will act always between the two bodies. Okay. So is it physical contact is necessary for Newton's third law? Physical contact. Is it physical contact is necessary for Newton's third law? That is what I am asking. Is it necessary?
Yes, sir.
No, it is not necessary all the cases. For example, if we take gravitational force and magnetic force, is it necessary physical contact? Physical contact
sir.
is not necessary. That is what you have to remember. So physical contact is always not necessary in where? In Newton's third law of motion. Is it okay, guys? Yes?
Yes, sir.
Yeah. So that is what all of you should remember. So if you'll understand this, then meeting is going to end. Join back. Then we will go with the illustration of, all of you keep reading, illustration of Newton's third law of motion. Illustration of Newton's third law of motion. That is what we can say examples also. Examples of Newton's third law of motion, or we can say in the illustration of Newton's third law of motion.